In December of 2014, a team at the University of Leicester published the result that should have closed the case. They had identified Richard III, not a legend, not a symbolic grave. The actual bones of the last Plantagenet king, buried for centuries beneath Leicester, in a place that had long since become a city car park. But folded inside the same DNA study was a second result, a quieter one. And this one did not close a mystery. It opened one. The maternal DNA matched. The archaeology matched. The wounds matched. The age, the spine, the burial location, all of it pointed to Richard. But the male line did not. The Y chromosome taken from the skeleton failed to match the living men who, on paper, were supposed to share Richard's royal male ancestry. Somewhere across roughly 19 father-to-son links connected to the Plantagenet line, the official family tree and the biology had split apart. The study could not say where. That was the disturbing part. The break could have sat in a place that changed nothing, a private family secret buried inside a noble line, or it could have sat in one of the places where blood was used to justify power, inheritance, and a crown. One skeleton had solved the mystery of a lost king. Then it raised a question England may never be able to answer. If the places where recorded history collides with hard evidence are the stories you come here for, then you're in the right place. Stay with this one all the way to the end, because the final piece is the one that reframes everything before it. For more than 500 years, the body of King Richard III was lost. Everyone agreed on the broad outline of what had happened to it. In August of 1485, Richard rode out to meet an invading army at a field near the town of Bosworth. He was the last Plantagenet king, the last of a dynasty that had held England for more than 3 centuries, and by the end of that day he was dead, cut down in the fighting, the last English king to die in battle. His body was stripped, slung over a horse, carried into the nearby city of Leicester, and buried without ceremony in the church of a Franciscan friary known as the Grey Friars. Then the friary was gone. When Henry VIII dissolved the monasteries in the 1530s, the Grey Friars was demolished, its stones carried off, its grounds sold and built over. The church vanished from the map, and with it went the grave. Over the centuries, a story took hold that Richard's bones had been dug up by a mob and thrown into the River Soar. As far as most historians were concerned, there was nothing left to find. Most historians were not Philippa Langley. A screenwriter and a member of the Richard III Society, Langley had become convinced that the king's grave had survived, undisturbed, beneath the modern city. Her research and the work of others before her pointed to an unglamorous location, a car park behind a council office building in central Leicester. She stood on that tarmac one day and by her own account, felt something close to certainty about a spot on the ground. Painted on the surface of one parking space was a single letter. The letter R. It marked a reserved bay. She could not shake the feeling that it marked something else. Intuition does not dig trenches. Langley spent years raising money and building a partnership with the University of Leicester and its archaeological services team, led by Richard Buckley. Buckley was a serious, careful archaeologist, and he was frank about the odds. Finding the friary at all would be an achievement. Finding the church within it would be luck. Finding one specific grave of one specific man, 5 centuries on, was the kind of thing that simply did not happen. He is said to have joked that he would eat his own hat if they actually turned up the king. The dig began in late August of 2012. And then something happened that archaeology almost never allows. On the very first day, in the very first trench, they hit human bone. Leg bones lying where a body had been laid. The team was cautious. Bones turn up on medieval sites all the time. They pressed on, mapped the buried walls, and slowly established what they were standing on. They had found the friary. They had found its church. And they had found, running through the middle of it, the choir, the high-status part of the church where the contemporary accounts said Richard III had been buried. The remains from that first day were lying exactly there. Buckley was frank afterwards about how unlikely all of this was. Archaeological digs are usually exercises in managed disappointment, a summer of careful troweling that turns up a few post holes and a broken pot. To open the first trench on the first day and strike the leg bones of the one man you are looking for, in the exact part of the church where the records placed him, is simply not how the discipline works. And so, for a long time, the team refused to let themselves believe it. The bones were treated correctly as an unidentified medieval burial. The name was kept at arm's length because they understood that hope is the enemy of evidence, and that the more they wanted this to be Richard III, the harder they would have to work to prove that it was. The task of lifting the skeleton fell to Joe Appleby, an osteoarchaeologist on the team. And as she uncovered the spine, she saw something that stopped everyone. The backbone did not run straight. It curved hard to one side, twisting into a pronounced sideways spiral. Here was a man of high status, buried in the choir of the right church in the right city, showing a spine that matched one of the few physical details history had handed down about Richard III. For 500 years, the propaganda had called him a hunchback. This was not that, but it was close enough to make the hair on your neck stand up. Now, a curved spine and a lucky location are a story. They are not proof. And the Leicester team knew that the moment they announced this was Richard III, the entire world would come looking for reasons to say they were wrong. So before anyone said the name out loud with any confidence, they took the skeleton apart, scientifically, one line of evidence at a time. And they started with the question of who this person had been in life, entirely separate from the question of his bloodline. The bones said this was a man, slender, almost delicate in build, which fit contemporary descriptions of Richard as slight and lean. The wear on the joints and the state of the skeleton pointed to someone who had died not old, somewhere in his late 20s or 30s. Richard III was 32 years old when he died at Bosworth. The spine was examined in detail, and the diagnosis was scoliosis, a sideways curvature that developed during adolescence. In life, it would have raised one shoulder higher than the other and taken inches off his apparent height, but it would not have produced a hump, and it would not have stopped him riding or fighting. It was almost eerily the body that the more careful Tudor writers had actually described, before the legend inflated it into something monstrous. Then there were the wounds. The skull alone carried 9 injuries. 2 of them at the back and base of the skull were catastrophic, the kind of blows that would have killed almost instantly, one of them slicing away a section of bone entirely. Others had been inflicted after death, into a body that could no longer defend itself. And that pattern lined up disturbingly well with the oldest accounts of how Richard died. Unhorsed in the marsh, his helmet gone, surrounded, killed from behind, then carried back to Leicester, not as a king but as a defeated enemy whose corpse could be degraded on the road. Every test so far was consistent with Richard III. But consistent is not the same as certain. Plenty of men in the 15th century died violently in their early 30s. So the team turned to the clock and asked when this person had lived. They radiocarbon dated the bone, and the first results came back slightly awkward, pointing a little earlier than 1485. But there was a known reason for that. A diet rich in seafood shifts radiocarbon dates, making bones read as older than they are and other tests were about to show that this man had eaten extremely well from the sea. Once the diet was accounted for, the corrected date landed comfortably in the second half of the 15th century, fully consistent with a death in 1485. That diet came from the isotopes locked in his bones and teeth, which record what a person drank and ate and where they lived at different stages of life. They told a story with a clear shape to it. A childhood in the east of England, then movement. And then, in the last years of his life, a sharp change. A sudden shift to a richer diet, more wildfowl, more fish, and a striking increase in wine. It is exactly the dietary signature you would expect from a man who, in the final couple of years before his death, had suddenly started living like a king. Because in the last 2 years before Bosworth, that is precisely what Richard III had become. Location, age, build, spine, wounds, date, diet. Line after line, the skeleton kept saying the same thing. But all of it, every bit, was still circumstantial. To close the case, the team needed something that could reach across 5 centuries and connect these bones to Richard III by name. They needed his relatives. And the only way to find them was to follow his blood forward out of the grave, down through the generations, and into the present day. Richard III left no surviving children. His only legitimate son had died in childhood before him, so there was no direct line of descent to test. But you do not need a direct line, you need a particular kind of relative. And this is where a genealogist named Kevin Schurer and a geneticist named Turi King come into the story, because between them they were about to attempt something genuinely difficult. To find living human beings in the 21st century who carried in their cells a molecular echo of a man who died in 1485. The echo they went looking for first was mitochondrial DNA. It is a small, separate loop of genetic code that sits outside the main nucleus of the cell, and it has one property that makes it extraordinarily useful here. It passes down only through the mother. A mother gives it to all of her children, but only her daughters pass it on again. Follow the all-female line, mother to daughter to daughter to daughter, and the mitochondrial DNA travels down the generations almost entirely unchanged. Which means that if you can trace an unbroken chain of mothers and daughters from a woman in Richard's family down to someone alive today, that living person should still be carrying Richard's mitochondrial signature. So Schurer traced it, not through Richard himself, but through his elder sister, Anne of York. Because Anne shared a mother with Richard, she carried the same mitochondrial DNA. And unlike Richard, she had descendants running down the female line. Schurer followed that female line forward across the centuries, generation after generation, until it arrived 17 generations later at a man living in London. His name was Michael Ibsen. He was born in Canada, and he made his living as a furniture maker, building and restoring pieces by hand in a workshop in the city. He was, as far as he was concerned, an ordinary man with an ordinary job. He was also, if the genealogy was right, the 17th generation nephew of King Richard III, connected to him through an unbroken chain of women stretching back to the 15th century. His late mother had been identified as part of this line years earlier. Now the question was whether the paperwork and the biology agreed. Turi King extracted DNA from the teeth and bone of the skeleton in the car park. Ancient DNA is fragile, degraded, easy to contaminate, and often simply unreadable. But it worked. She recovered a mitochondrial profile from the bones. Then she compared it to a sample from Michael Ibsen, and they matched. Recovering that profile at all was an achievement. DNA does not survive the centuries intact. It shatters into short fragments, it is eaten away by bacteria, and any grave is a minefield of contamination the genetic material of everyone who has ever handled the bones layered on top of the material you are actually chasing. King worked from the teeth and the dense inner bone, the places where genetic code is best shielded from time, under strict protocols designed to keep modern DNA out. The mitochondrial DNA was the natural first target, for a simple physical reason. Every cell holds a single nucleus. But hundreds of mitochondria, which means hundreds of copies of that little maternal loop for every one copy of the main genome. When you are scraping fragments out of a 500-year-old tooth, having hundreds of copies to work from is the difference between a result and a blank. To strengthen the case, they had also traced a second, entirely separate female line descendant of Anne of York, a woman named Wendy Duldig, 17th generation kin along her own distinct chain of mothers and daughters. Her mitochondrial DNA was tested too. It matched as well, differing by just a single base. Two living people on two independent female lines running back 5 centuries to the same royal family, both carrying the same rare maternal signature as the bones in the grave. That signature belonged to a relatively uncommon mitochondrial type, a maternal lineage geneticists label J1c, 2c, uncommon enough that a chance match with two independent relatives strained credibility. So the team did what good scientists do with a pile of independent clues. They combined them, formally, using a statistical framework that weighs each piece of evidence and multiplies the case together. The radiocarbon date, the scoliosis, the wounds, the male build, and the right age, the burial in the choir of the correct church, and now the mitochondrial DNA matching not one but 2 traced relatives. Run together on the conservative end of the assumptions, the numbers gave a probability of at least 99.999% that the skeleton in the Leicester car park was Richard III. In the careful language of the courtroom, this was identity beyond reasonable doubt. And that, as far as the headlines were concerned, was the story. The lost king found, named, and confirmed by his own DNA. It was one of the most complete forensic identifications ever made of a historical figure. The maternal line had held all the way down for 500 years. The case was closed. Except the team had run one more test. They had also looked at the male line, the father-to-son line, fully expecting it to be a formality, one final confirmation to sit alongside all the rest. Instead, it did the opposite. The male line was a different piece of DNA entirely, and it behaves almost like a mirror image of the first. Mitochondrial DNA runs down the female line. The Y chromosome runs down the male line. A father passes his Y chromosome to his sons, and only to his sons, and they pass it to theirs, largely unchanged, generation after generation. It is in effect a genetic surname. 2 men who share a male line ancestor should carry very nearly the same Y chromosome, no matter how many centuries separate them from him. If you know the family tree, you can predict the biology, and that is exactly what makes it such a dangerous test. Geneticists sort these male lines into large families called haplogroups, and then into finer patterns within them, essentially the specific spelling of a man's genetic surname. Close male line relatives share that spelling almost exactly. Random mutations do creep in, but slowly, one tiny change every few generations. Nothing like the wholesale difference between one family and another. So when 2 men who are supposed to share a recent male line ancestor turn out to sit in entirely different haplogroups, mutation cannot rescue the family tree. The gap is simply too wide. The only explanation that fits is that somewhere between them, a son was not the son of his recorded father. That is why this test is so unforgiving. It does not deal in shades of doubt. Either the line holds or it does not. Richard III had no sons to carry his Y chromosome forward. So, once again, the researchers had to go sideways and backward, up the family tree to find a shared male ancestor, and then down another branch to living men. They climbed all the way up to Edward III, the great Plantagenet king from whom Richard descended, and then came down a different male line through Edward's son John of Gaunt, and through the family that sprang from him, the Beauforts, down the centuries to the Dukes of Beaufort, and finally to 5 living men descended from Henry Somerset, the 5th Duke of Beaufort. These 5 men were, on paper, distant cousins of Richard III along the male line, which meant their Y chromosomes carried a clear, testable prediction. All 5 should broadly match each other, and all 5 should, in turn, match the man in the grave. This was supposed to be the easy part. The paperwork on these families was among the best documented in the country. Dukes do not lose track of their own descent. The results broke the prediction in 2 different ways at once. First, the 5 living men did not all match each other. 4 of them shared a Y chromosome type. The 5th did not. He sat in a completely different genetic group, which meant that somewhere along his particular branch, in the recorded chain of fathers and sons, at least one son had not been fathered by the man the records named. And second, and far more importantly, not one of the 5 matched the skeleton. Richard III carried a Y chromosome from a rare lineage that none of his supposed male line cousins shared at all. Richard's own Y chromosome, recovered from the grave, belonged to an uncommon lineage, one carried by only a small fraction of European men. And that rarity cut in 2 directions at once. It made the mismatch with the Somerset men unmistakable, and it closed off the easy, comforting explanations. This was not 2 common signatures blurring together by chance. It was a distinctive genetic surname in the grave, and a completely different one in the men who were supposed to share it. The consequence of that mismatch takes a moment to land. The mitochondrial DNA, the female line, had supported the identification. This was Richard III, and that was not in doubt. This was Richard III. But the male line, the line that is supposed to carry a king's name and a king's crown from father to son down the centuries, did not connect him to the very family whose whole claim to nobility rested on being his blood relatives along that exact line. Somewhere in the chain of fathers and sons linking Richard III to those living men, the official record and the biology had parted company. Somewhere a child recorded as the legitimate son of one man had actually been fathered by another. There is a clinical term for this. Geneticists call it a false paternity event or a non-paternity event. Stripped of the jargon, it means something very old and very human. The man on the record is not the biological father, but the DNA cannot tell you why. It could have been an affair. It could have been an illegitimacy that was already hidden inside the family. It could have been a record that turned a social father into a biological one with a single stroke of a pen. The science cannot recover the human story. It can only tell you that, at some point, the paperwork and the blood stopped agreeing. And until the invention of DNA testing, that kind of break was, in almost every case, completely undetectable. It could sit inside a family for 500 years and leave no trace at all until someone opened a grave. How often does this actually happen? Studies of paternity in historical and modern populations tend to land on a similar range, somewhere around 1 to 2% per generation. In any single handoff from father to son, that is a small number. You could look at it and shrug, but this chain was not 1 generation. It was roughly 19 of them, from Edward III down to the living men who were tested. And probabilities do not stay small when you stack them. Run a 1 to 2% chance across 19 generations, and the odds that at least one break occurred somewhere in the line stop being a curiosity and start being something close to expected. The researchers were careful to point this out. A break in a line this long is not a scandal. Statistically, it is almost the default. And here is the detail that gives the whole thing its edge. The male line the researchers had climbed, the Beaufort line running down from John of Gaunt, is not just any branch of the family tree. It is the branch through which the Tudor dynasty claimed the throne of England. Margaret Beaufort, a descendant of that same Beaufort line, was the mother of Henry Tudor. And Henry Tudor was the man who defeated and killed Richard III at Bosworth, took the crown for himself, and founded the dynasty that would run through Henry VIII and Elizabeth I. The legitimacy of the house that replaced Richard ran, in part, through the very bloodline that the DNA had just shown contained a break somewhere along its length. And this is the moment to say plainly what the study does say and what it does not, because the difference matters enormously, and it is where less careful tellings of this story go badly wrong. The DNA does not prove that Richard III was illegitimate. It does not prove that Henry Tudor was illegitimate. It does not prove that any specific king was the product of a false paternity event. Turi King and Kevin Schurer were emphatic on this point. What the DNA proves is that a break exists somewhere in 19 generations of that male line. It does not and cannot tell you which generation. The break could sit in a quiet, undistinguished stretch of the family, centuries away from any throne. It could just as easily sit somewhere that matters a great deal. The science identifies that the record is wrong. It is silent on where. Richard III, of all people, understood how flimsy that claim could be because he had built his own reign on attacking it. When his brother, King Edward IV, died, the crown should have passed to Edward's young son. Instead, Richard took it by having that son declared illegitimate, arguing that Edward's marriage had been invalid and that the boy, therefore, had no true claim. The two young princes, Edward's sons, were lodged in the Tower of London and then were never reliably seen again. Whatever became of them, the mechanism Richard used to justify taking the crown is the part that matters here. He did not need DNA. He needed only an argument about legitimacy. Because in the 15th century, an argument was all legitimacy ever was. A claim about blood that no one could confirm and no one could truly refute. Richard turned that uncertainty into a throne. 5 centuries later, his own bones would reveal just how deep the uncertainty went. Step back from this single family tree, though, and look at what has actually happened. For centuries, monarchy rested on a simple claim. That blood knew the truth, that the right to rule was carried reliably from father to son. But that blood was never actually tested. It was written down, witnessed, defended, fought over, and sometimes killed for, and never once confirmed. Coronations took it on faith. Successions took it on faith. The Wars of the Roses were fought over rival readings of a thing no one could verify. Only in the 21st century, with a skeleton on a laboratory table, was one of those royal lines finally put under a microscope. And the result was not clean. It is tempting to run the line forward and ask what all of this means for the monarchy on the throne today. The answer is far less than a headline would like. The modern royal family does not hang its position on an unbroken male line thread running cleanly back to Richard III or his cousins, and a single break in one branch of one 15th century line cannot be stretched into a verdict on anyone now living. The unsettling implication was never about a particular modern face. It is about the machinery itself. The discovery does not tell us that today's crown is illegitimate. It tells us something more corrosive, that the standard by which such things were judged for 1,000 years was never once capable of being checked. Which leaves us with a question that has no answer and may never have one. We know the break is there. We do not know where it sits. And because we do not know where it sits, we cannot rule it out of the places where it would matter most. If it falls in one stretch of the line, it is a footnote, a piece of gossip about a duke 5 centuries dead. If it falls in another, it means that a crown may, at some point, have passed on the strength of a claim that biology would not have supported, and that no one, then or now, would ever have known. The records that might tell us which are gone, or were never written, or are the very records the DNA just proved could be wrong. The families kept careful trees. The trees were the whole point. And the trees, at least once across those 19 generations, recorded a father who was not the father. The one document that would settle it is precisely the kind of document that has just been shown to be unreliable. Even the question of where to lay him became a fight. Once it emerged that the king had been found, a legal battle broke out over his bones. The city of York, with which Richard had strong ties in life, argued that he should rest there. Leicester, where he had lain for 5 centuries, argued that he should stay. It went to the courts. Leicester won. And so in the spring of 2015, in a service carried live around the world, the last Plantagenet king was borne through the streets and laid beneath the floor of Leicester Cathedral, a few hundred meters from the car park where he had spent the previous 500 years. A king was handed back his dignity. The break in his family's blood was handed no such resolution. The less dramatic answer is also the more unsettling one. The search for Richard III succeeded completely. He was found and named and given back everything a lost king could be given back. But the same test that returned his name took something else away from the whole idea of royal legitimacy. For centuries, England said the right to rule lived in the blood, and never once checked whether the blood was telling the truth. When this royal line was finally checked, the paperwork and the blood did not agree. And somewhere across those 19 father-to-son links, the throne may, depending on where the break sits, have passed through a claim that biology would not have supported, with no chronicle, no confession, and no way left for history to tell us when. The break in Richard's family line is still there, sitting in the data, still unplaced, still unresolved, and it will almost certainly stay that way. If stories like this one, where the evidence outlives the official version, are what you come here for, then follow along, because we go looking for the next one every week. The records kept the official version, the DNA kept something else. And 500 years later, it was still there.